that up. All right, guys. So we're gonna rock and roll with stoichiometry today. We posted a video yesterday of how to do it, and we're gonna just continue some examples today. On your practice yesterday, all of the answers were provided to you. So I really want to see your work. I want to see you working through it. I want to see your parentheses, putting what you don't want on the bottom, what you do want on top. Make sure you got it all straight like that. I'm going to start off with the very first question on today's practice. So this is 10-28-20 stoichiometry 02 is the name of the assignment. And we'll work it together and kind of probably do maybe one or two more and then answer any questions anybody has and then go from there. So first off, I need it on my board here. We got sodium chloride plus sulfuric acid. And that's going to yield hydrochloric acid and sodium sulfate. All right, so the last test was so important because nothing in this test, nothing in this unit matters unless you have a tool that the last test gave us. What was that tool that the last test gave us? What did we do on the last test? We took an equation like that, and what did we do to it? No, we didn't simplify it. We balanced it. Because right now, this story is not telling us anything. Yesterday, the bell ringer, some people got a kick out of about the making the Big Macs, okay? You don't know how to make a Big Mac unless somebody tells you how many burgers and how many buns to put on it, okay? So for me to tell you how to do this chemical formula, I need to tell you how many sodium chlorides are going to hook up with sulfuric acids. To do that, it's got to be balanced. So the first step for all of these problems this week is to balance your chemical equation. You have to be able to balance it before you can do anything else. Okay, so let's do that real quick. How many sodiums? One there, two there, throw a two. Two chlorines, one chlorine, throw a two. Two hydrogens, one sulfur, four oxygens, four oxygens. Pretty straightforward, right? Okay. So now that we have a balanced chemical equation, we have a tool that can take us through all of our steps. Okay. And if you're at home, you can't see this. Bring up the island diagrams for when we did work before. I'll draw it on the board here in a second, but I'm gonna put our island diagram that we can refer to over here because this is how you go to everything. Because we have a magic word in chemistry called mole. And mole takes you anywhere you want to go. Okay, we did this at the beginning of the year. No matter what you're talking about, you can change from moles to particles. My magic number, 6.02 times 10 to the 23rd. There are 6.02 times 10 to the 23rd particles in 1 mole. Now, a particle can be an atom, a molecule, a piece, whatever way you want to say it. It can be a particle. You can also change to mass, grams. And to do that, you look on the periodic table. The grams on the periodic table equals 1 mole. One thing we added yesterday that we didn't talk about before that's really quite easy because it's our black box over there is volume. If you have a mole of gas at standard temperature and pressure, which we'll talk about later, that's going to always equal 22.4 liters in 1 mole. Okay, so just sketch that out real quick for my folks at home. Mass, mole, particles, volume. Okay, for here, we're going to look at the periodic table. Here, we're going to say 6.02 times 10 to the 23rd particles And here we're going to say 22.4 liters. This is all for 1 mole. 1 mole, 1 mole, 1 mole. Now, once you get to moles, you can change what you're talking about in the balanced chemical equation. And so that's where this is going to take us. Okay? So if you're at home, feel free to pause and write this down. I'm going to leave it up on the board here in class. Now we go back to that strategy that we used way back at the beginning of the year, where you read the question, you write down what you want, and you do what you need to do to get to where you want to go. First question says you got 359 grams of sodium chloride. So I'm going to just write that right here. 359 grams of sodium chloride. That's sodium chloride. You got 359 grams of it. That's all I need to know for the first sentence. Was the first few words are consumed in the reaction. So we know we're over here, we're going away in the reaction. And it wants to know how many molecules of sodium sulfate do you produce. So you got 359 grams of that. I want to know how many molecules of that. What word on my little whiteboard over there is molecules?
Molecules is that, no, the
particles. Little pieces. Molecules is a particle. Okay? So now we're just going to take it through the steps here. We're going to write down exactly what we have. 359 grams of NaCl. We're going to draw our fraction. Taking it back to that rhythm that we talked about before earlier in the year. We have 359 grams of sodium chloride. I don't want grams of sodium chloride, so where do they go? On the bottom. Grams of NaCl. Now look at your chart over here. Grams is which of these three? Mass. What's the only place I can go from mass? No. Look up here. What would the only other place I can go? There's only one line that's leading from mass. And where's it going? To moles. So I'm going to change grams of sodium chloride to moles of sodium chloride. And you're exactly right. We look at the periodic table. If we're going from something that's not moles to moles, we have 1 mole. Now we need a calculator to figure out how many grams of sodium chloride. We ready with our calculator? So first off, we need Na. What's my number?
Wait, I can't see it. Like 20, is it like 20 something?
23. 22.98, 23. Okay, I'm going to add 23 to my Cl. 35.5. 23 plus 35.5. And that is my grams in 1 mole of NaCl. What we got?
Is it 1?
23 plus 35.5 is definitely not 1.
Oh, sorry.
58.5, let me get agreement.
Yeah.
Okay. All right. Now, if I stop there, I'll get moles of sodium chloride. Is that what I want? Of course not. So I'm going to draw myself a new fraction. And since I don't want moles of sodium chloride, I'm going to put them on the bottom. Here's where it gets, this is the only step that is different from what you did earlier in the year. It's the only step that's a little bit different. Because I have an entire tool on the board that's showing me for every piece of sodium chloride, how many pieces of sodium sulfate. What's the ratio? How many pieces of sodium chloride do we have? 2. How many pieces of sodium sulfate do we have? So what my ratio is 2 to 1. So for every 2 pieces of sodium chloride, I have 1 piece of Na2SO4. This is what's called your mole ratio. It's the ratio that takes you from one element, one molecule, to a completely different molecule. Now we go back to our question. Do we want moles of Na2SO4? What's the question asking me for? Does it say how many moles? says how many what? How many molecules? I got one more step. I don't want moles of Na2SO4. And write that so it's not quite so sloppy. I want molecules of Na2SO4. Now here's what's pretty cool. It doesn't matter what you're talking about. You're going to use the same exact number for this always. Because a molecule is another word for y'all told me earlier, what word? It's another word for a particle. So my magic number is going to be 6.02 times 10 to the 23 in 1 mole. Now here's what's cool. Me and Mr. Salivi, Mr. Butterworth, our chemistry teachers at this school, are firm believers in the theory side of chemistry. We are not grading you on math. Okay, and this is what I mean by that. If you give me that, and then you screw up the world on your calculator, probably going to give you a 90. A 9 out of 10 on that question. If you set it up perfectly, but you can't, you make a mistake pushing the buttons on the calculator, I'm probably going to give you a 9 out of 10, which is an A. So don't panic on getting the calculator buttons right. I'm going to teach you how to do it, but don't panic on it. I'm going to let Miss Baker and Mr. Byram and Miss Abmay and Mr. Leggett handle that. Okay? We're going to do the setup. And so your majority of your grade is going to be that right there. Now, that being said, if you don't show me that and all you give me is an answer, it better doggone be right. Does that make sense? Because then I got nothing to give you because you didn't show me anything. Yes, sir. Sure. All right, so let's check this math out. This is how I would do the math. When it comes to math, I'm not teaching you math. I'm teaching the buttons to push on your calculator. Okay? So for my folks at home, for my folks in the classroom, follow along and let's get the Mr. Tire instructions for how we're going to knock this baby out right here on the calculator. Okay? So first off, I'm going to put in 359. What's the first math you think I'm going to want to do? 50-50 shot. Multiply or divide. Dividing's up there, but the first thing I'm going to want to do is multiply. Because you need to multiply before you can get your big dividing going. And I'm going to multiply everything on the top. 359's on the top, and there's only one other thing on the top. What is it? Very good. So let's type that guy in. Times 6.02. Now, does everybody remember how to do times 10 to the 23rd? It's been a while. Second, so 6.02. Second, the EE button, 23. So let's make sure everybody's on the same page there. My calculator is kind of scrolled off, but I see 59. It says 359 times 6.02 E23. Everybody good? 359 times 6.02 E23. Okay, I'm gonna smash the enter button. Big old stinky number, 2.16, blah, blah, times 10 to the 26. Who cares? That's a halfway point number. I don't really care about it. Everybody good? Now I'm going to need to divide by everything underneath the bottom. So here's how I'm going to do that. I'm going to hit divide. So it comes up answer, divide. I want to divide by everything. So I'm going to start some parentheses. Divide, start my parentheses. 58.5. And then what am I multiplying by? What's the only other number on the bottom? 2. 58.5 times 2, and then close my parentheses, and then smash the enter button. Big calculator screen full of answer, isn't it? Okay, let me tell you the only thing that's important in that answer. Let's look at this. First off, I'm going to look back at what they gave me. They gave me 3 numbers. Guess how many numbers I'm going to give them? That makes sense. If they gave me 3 numbers, I'm going to give them 3 numbers right back. So I'm going to look at my calculator. I'm going to read the first 3 numbers. 1.8 But then I'm not going to put 4, I'm going to put what? Because that 7 brings that 4 up. 1.85. Then I'm going to go to the end and not forget the rest of my number times 10 to the 24. Okay? Now forget something. Make sure I didn't screw something up here. Somebody came in and left. That's no fun. Oh, I never turned my camera on, I think. Whoops. I'm holding that camera up to the doggone screen and not doing nothing. Lord, mercy Jesus. I'm gonna hold my camera up doing nothing the whole time. I'm sorry, folks at home. I'll do the next one for you too. But 1.8, but they were sharing my screen, I just wasn't sharing the video. 1.85 times 10 to the 24th, but remember our rule from way back at the beginning of chemistry, numbers by themselves in chemistry mean nothing. 1.845 times 10 to the 24th, what? What was I trying to get? Molecule.
Is it M1?
It's like, let me try to my pretty fancy handwriting. Here we go, ready? So the whole word is molecules. That's the whole word. Can't just use M because that looks like mass. I can't just use MOL because that looks like moles. So I need something different, and the way that you write it different is M. If I can write it M apostrophe C. Molecules. And I ain't gonna be mad at you. If you write out the word molecules, you still be good. If you put MOL, I probably know what you're talking about, but it keeps it from being confusing with MOL, which is moles. Cool? And like all these little squiggles right here is MOL for moles. Okay? So you guys lucked out. There's only what, 5 questions on today's practice? I'm gonna go ahead and do the second one because I didn't have my camera turned on. So you guys lucked out. Get 2 out of your 5 questions given to you for free. Everybody good?
No.
All right, let's knock out this next. Any question anywhere in there where you're like, man, where'd you do that? Why'd you do that? You gotta speak up because I'm, I feel like when I don't hear anything that we're rocking and rolling. So I'm assuming we're rocking and rolling. All right, so let's check out this next one. We got some silver acetate. Is that right?
No.
Yep. Calm down, Martin. And we're adding sodium phosphate. And we're going to end up with silver phosphate.
No, we're not.
Martin, calm down, bud. And sodium acetate. It's already on your paper. I had to write it down because people could see it, but you already should have it. All right, we got a balance spool. 1 AG, 3 AGs. I'm going to save C and O for last because they're all over the place. 3 H's, 3 H, or excuse me, 9 H's, 3 H's. 3 NAs, 3 NAs, 1 P, 1 P, 4 O's. Well, we got a bunch of O's. So let's do C, 2 C's. Excuse me, 2 times 3 is 6 C's. 2 times 3 is 6 C's. 2 times 3 is 6 O's plus 4 O's is 10. And 4 O's plus 6 O's is 10. Kicking tires, lighting fires. Feel good? That's kind of a weird one, but it's because I squished the things up there. Okay? So let's read the question. What mass of AgCH3COO, how many grams of that fool, will react with 4.77 molecules of sodium phosphate? 4.77 times 10 to the 26 molecules. So we only care about the beginning of this problem. The second half of this problem kind of squished anyway, so that's probably pretty good. So we write down exactly what we have. 4.77 times 10 to the 26 molecules of, I'm going to just use N and A. Okay, we're only dealing with these 2 things, sodium phosphate, silver, blah, blah, blah. So I'm going to just use N and A to save myself some room because it's a bunch of crap. Everybody cool with that? So N. Do I want molecules of sodium phosphate? Where are they going? On the block. And so I'm going to change those molecules of sodium, blah, 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 to moles of sodium, blah, blah, blah. What's my magic number? Magic number for moles is 1. I don't disagree with that. What's my magic number when I'm dealing with molecules? Molecules is another word for a particle. 6.02 times 10 to the 23. All right. I don't want to be talking about N, so I'm going to put moles of N on the bottom. And what's the only thing that I can change to of something different? Moles of N to... Can I go from moles of sodium to grams of silver? Can I go from moles of sodium to liters of silver? So what I can do is go from moles of sodium to moles of silver. How you go from one element, from one molecule to a completely different one is moles to moles, because that's where your numbers from your equation matter. How many moles of silver do we have? 3. And how many moles of sodium do we have? What number's right there? What number's right there? 1. And then we finish it up by saying we don't want moles. Where do they go? On the bottom. We want grams. Now I need your calculator again. So we got to figure out how many grams are in that pool right there. Everybody ready with your calculator? Martin, help me out with the calculator, bros. I'll even give you the numbers. Make sure you don't squint your eyes. We have 1 silver. Silver is 107.9. 107.9. Then we're going to add a carbon, which is 12. So plus 12. We're going to add 3 hydrogens, which are 1 apiece, which would be 3. Right? If you want to be fancy, you can do 1 plus 1 plus 1, but you all know that's 3. Then we're going to add another carbon, which is 12. Then we're going to add 2 oxygens, which are 16 apiece. So you can either say plus 16 plus 16, or you can say just plus 32.
166.9.
See if somebody agrees. 166.9 sounds good to me. So that's how you get a mass of a whole big thing. You just add it all up. Wow. 166.9. That's an ugly number. My thing kind of got off a little bit. Sure. All right, let's math it up. My folks at home, I apologize I didn't show you the calculator last time, so I'm going to show you the calculator this time. All right. So let's check this one out. I'm going to start off typing in the number we started with. 4.77 times 10 to the 26, E 26. So 4.77, second, E button, 26. And we're going to multiply by what? Nah, you're not going to multiply by 6.02. What are you going to multiply by? Always multiply across the top, multiply across the bottom, and then divide. So we're going to multiply that number times, what's the next number on the top? Say it loud. 3. Times 3, and then the next number on the top? I'm down, bro. 166.9. So we did the big number times 3 times 166.9. We smashed the enter button. We get 2 point something times 10 to 29. Then we're going to divide by everything on the bottom. We're going to divide by everything on the bottom. So I'm going to start my parentheses. Well, no, actually, never mind. Let me take it back. I don't need parentheses. Why? How many numbers that aren't 1 are on the bottom? Just 1. So we're going to divide by 6.02. E23. 6.02, E23. Then we're going to smash our enter button. We've got a nice, pretty number there. This one isn't even all that big. It's pretty big, but it ain't as big as some of the other ones. Same thing. The question before gave you three numbers. Might as well give three numbers back. 397. And if you want to write that whole number, I ain't going to be mad at you. So I just took the first three numbers. And we're not just talking about the number 397,000. We're talking about 397,000 what?
No.
Nope.
This particle?
Nope. Look at where you end. Look at what you want. Now, the question didn't want molecules.
Wait.
Mass, which is measured in
No, it's grams.
grams. That's why I write it up there like that. I write it up there like that so that I know to go back to it. Easier? So Mr. Salidi, I'll be honest with you, he gave you only 5 problems for practice. We just did 2 of them because what he did was he'd rather give you a little amount that are really hard than a bunch of easy ones. Okay, so I want to do a couple really easy ones that aren't on your practice sheet. Okay, that you'll see more of on the test. So let's check this out. Let's look at. I'm gonna do a question off of this one, but not use the numbers that he has. So HGO yield decomposition to Hg and O2. Okay. First thing before I can do anything else, you got to balance this fool. 1 Hg, 1 Hg, 1 O, 2 O's. But that also makes 2 Hg, so 2 Hgs. All right. Who's your favorite basketball player, Martin?
Giannis Antetokounmpo.
What's his number?
34.
34. All right. So if I have 34 moles, if I have 34 moles of HGO, I want to know how many moles of both of these I'm going to make. Okay. So let's do those 2 problems. 34 moles of HGO and 34 moles of HGO. Now, luckily, I'm going to have the same thing on the bottom of both, right? Because what do I have and not want? What do I have? Moles of HGO. Goes on the bottom of both. Moles of HGO, moles of HGO. Now, here's a mistake somebody's going to make on this test next week. Somebody's going to make this mistake, guaranteed, no doubt about it. They're going to think, ooh, how many moles of HGO do I have? Oh, I have 34. Look what I just did. Where is 34? It's on the outside of parentheses. Does that mean it's on the top of the parentheses? When it's on the outside of parentheses, is it on the top or the bottom of the fraction? Any number written by itself, is it on the top of the fraction or the bottom of the fraction? On the top. Now, where else is 34? It's inside the parentheses on the bottom. If you got a number on top of the parentheses, or excuse me, a number on top of the fraction and a number on the bottom of the fraction, what can you tell me? If I put 2 on the top of the fraction and 2 on the bottom of the fraction, what's my fraction? If I put 1,038 on the top of the fraction and 1,038 on the bottom of the fraction, what's my fraction?
1.
Okay? So when you put a number on the top and on the bottom, what did you just do? You just did nothing. You with me? You understand what I'm saying? Anytime you put a number on the top and the bottom, you just did nothing. So all you did by putting 34 on the bottom here was you just canceled the work you've done so far. You're not going to put this number here. You're only going to put what you got here. When you start putting numbers into parentheses, you're not going to use the numbers you're given. You're going to use the numbers that you have with your tools. If we're talking grams, you're going to look at the periodic table. If we're talking molecules or atoms or particles, you're going to use that number right there. If you're talking liters or volume, you're going to use 22.4. And if you're talking moles to moles, which is what this is about to be, moles of HGO to moles of Hg here, and moles of H2O to moles of O2 here. When we're going moles to moles, you get your number from the balanced chemical equation. 2 moles of H2O is in the balanced chemical equation. How many moles of Hg? 2. And how many moles of O2?
1.
Man, this is some tough math right here. Anybody want to knock this math out without a calculator?
Wait. 38.
Where'd you get 38?
34. Oh.
What's 2 divided by 2? 1. What's 34 times 1?
34.
Rock and roll.
Oh, I added them all together. That's how I got 38.
All right. Slightly harder math down here on the bottom because we're going to say 34 what?
Moles.
34. Then what are we going to do?
Still have to figure out what you hit them like.
No, we got the units up there. Units ain't a problem. All we got to do is math.
34 times 2.
Why we multiply? Wow. Think about it, guys. Look, this is what y'all, everybody says they're not good at math until you start talking about money. Okay? If I'm telling you you're getting half your paycheck, are you getting more money or less money? You multiply and you divide. You with me? You with me? Okay? So like everybody knows what that is, but like, so when I say 1 over 2, am I gonna multiply or divide? When I say 1 over, you get half your paycheck, you're gonna multiply or divide. Very good. When I say 1 over 2, you're gonna multiply or divide. Y'all with me? Okay, when numbers on the bottom, you're going to divide. When numbers on the top, you're going to multiply. Okay? So I'm going to say 34 divided by 2. If you want to get fancy with your calculator, you're welcome to it. I'm pretty sure it's 17, though.
Yeah, I think it is.
And that's it. We just did 2 baby problems in the middle of that. Most of your test is going to be like this, where you take one little step. You look at your mole ratio. You go from moles of one thing to moles of another thing. You'll have a couple problems that are like the first 2 we did, where you got to take 3 steps. But most of our problems are going to be 1 step like that right there. Cool? Rock and roll, guys. Got the rest of the day to practice. If you do the practice in class and you show it to me, don't have to worry about submitting anything. I'll go ahead and give you credit. And yeah, that's it. If you do anything else, let me know. This is your last grade on the 6 weeks. So you're making the grade what you want to make it. Got any questions, Zach?